Good morning, students. So in the last class we discussed the topic part C, right? So in revision, so fifth question is completed. So today start with the question number 6, right? So derive the expression for energy stored in a charged capacitor, right? Energy stored in a charged capacitor, right? So here we are considering the capacitor, that is with the parallel plate capacitor, right? So initially considered two uncharged parallel plate conductors, right? So first we are considered two uncharged conductors. So uncharged conductor means, so initially the charge on each conductor is 0, right? So here we are going to charge this capacitor. So that is the energy which is stored in the capacitor, right? So energy stored in the charged capacitor derivationally. So initially we are considering the two conductors, so two parallel plate conductors, right? So two parallel plate conductors, initially those are uncharged. That means ಯಾವುದೇ charge ಇರೋದಿಲ್ಲ, right? So now we are bringing the charge from second conductor to the first conductor, right? So consider two conductors. So the first one we taken as conductor 1 and the second conductor we taken as second conductor, right? So we are bringing the charge from second conductor to the first conductor, that is the positive charge. So conductor ಅಂದ್ರೆ ನಮಗೆ charge carriers ಯಾವುದು ಇರುತ್ತೆ, electrons ಇರುತ್ತೆ. We are bringing the electrons from the second conductor to the first conductor, right? So second conductor in the one electron ತಗೊಂಡು we are charging the first conductor, right? So we are removing the electron from the second conductor and it is added to the first conductor, right? So again it gains the electron and it loses the electron. So the conductor which gains the electron, it is positively charged, and the conductor which loses its electrons, it negatively charged, right? So here minus. So the process will continue by step. So in process next we are removing one more charge, right? So it gets negative. So second conductor ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, negative charge ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So first conductor ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, positive charge ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So due to this the electric field is established from positive charge to the negative charge, right? So considering an intermediate situation. So intermediate situation means, so ಯಾವುದಾದರೂ ಒಂದು particular time ಅಲ್ಲಿ we are bringing the charge. So which charge it is? Positive charge from second conductor to the first conductor. So in the electric field, so electric field is from left to right. So we are bringing the positive charge from right to left, right? So illenagtade namage work agtade. So electric field ide andre, so there is a force. So electric force irutte. So force ide jotege charge enagtade, displace agtade, that is by a distance. If we take on that distance as d, so two conductors middle ಅಲ್ಲಿ d ಅಂತ distance ತಗೊಂಡ್ರೆ charge ಏನಾಗ್ತದೆ, displace ಆಗ್ತಾ ಇದೆ ಯಾವುದರಲ್ಲಿ, in the electric field, that is the external field which we are given, right? So ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ, work done ಆಗ್ತಾ ಇದೆ. So first we need to find the work done, then that work done is equals to the energy stored, right? So considering the intermediate situation, so the first conductor, the charge is q dash and the second conductor charge is minus q dash, right? So initially uncharged conductors ಇದ್ದಿದ್ರಿಂದ q dash value ಏನಿತ್ತು ನಮಗೆ 0 ಇತ್ತು. So after some time the charges on the two conductors becomes q dash and minus q dash, right? So completely charge ಆಯ್ತು ಅಂದ್ರೆ q dash is equals to q, right? So ಇಲ್ಲಿವರೆಗೂ ಕಂಪ್ಲೀಟ್ ಆಯ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ, completely the charges are stored in the capacitor. So we are bringing the small amount of charge from second conductor to the first conductor, hence so small work done is done, right? So at any intermediate situation right? So Q dash is the charge on first conductor, minus Q dash is the charge on second conductor, right? So V dash is the potential between the conductor, right? So here electric field is there, so displace after the charge, so hence work is done, right? So work done, so that is the small we take on that one as dW, right? So work done, dW is equals to intermediate situation with the V dash into, so small amount dq dash. So dq dash is the small charge which we are bringing from the second conductor to the first conductor, right? So small work done dW, that is equals to V dash into Q dash, right? So from the definition of the capacitance, right? So from definition of capacitance, C is equals to Q dash divided by V dash, right? So generally Q by V and the intermediate situation in the Q dash by V dash. So from this relation, V dash is equals to Q dash divided by C. So substitute V dash into work done, right? So dW is equals to Q dash dQ dash divided by C. So this is the small work done. So to find the total work done, so number of the charges increases on both the conductors, right? So total work done, right? So W, that is equals to integration. So charge ಎಲ್ಲಿಂದ store ಆಗಿದೆ, initially charge 0 ಇತ್ತು, so ಎಷ್ಟು store ಆಗಿದೆ, Q ಅಷ್ಟು store ಆಗಿದೆ, so limits becomes 0 to Q, right? So initially it is uncharged conductor, that is uncharged capacitor, so this capacitor is charged to Q, right, into dW, right? So 0 to Q, so dW is Q dash dQ dash divided by C, Q dash dQ dash divided by C, right? So C is constant, so we can take outside, so integration of Q dash, that becomes Q dash square divided by 2, so limit 0 to Q, right? So now W is equals to upper limit Q square minus 0 divided by 2C, right? So this is one form of the energy stored in the capacitor. So this work done is stored as energy, so U is equals to 1 by 2 Q square by C, right? So from the definition 1 by 2, so Q is equals to C into V, so C square V square divided by C, so C square cancel, so energy stored is 1 by 2 CV square. So this is the energy stored in a capacitor, right? So 3 marks is very important. So tumba explanation enilla. So initially consider two uncharged conductors, right? So initially two uncharged conductors na consider ಮಾಡ್ಕೋಬೇಕು. Next intermediate situation, so bringing the charge from second conductor to the first conductor. So second conductor in the first conductor ಗೆ ಒಂದು charge ನ ತಗೊಂಡು ಬರ್ತಾ ಇದ್ರೆ, so that is conductor ಅಲ್ಲಿ electrons are the charge carrier. So if we remove the electron from the second conductor, it becomes negative charge, so that electron is gained by the first conductor, so hence the conductor becomes positive charge. So ಇದು ನಮಗೆ step by step bit by bit ಅಂತ consider ಮಾಡ್ಕೊಂಡ್ರೆ, so at any intermediate situation, so ಯಾವುದೋ ಒಂದು intermediate situation the charges which is stored on the conductor one is Q dash, and the charges which is stored on the second conductor is minus Q dash, right? So that Q dash initially ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ, right? So after certain time the fully the electric charges are moved from the second conductor to first conductor, then the capacitor or conductor gets fully charged. So up to that extent, that is the Q, right? So that is the consideration, right? So electric field ಇದೆ. So electric field ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ force ಇರುತ್ತೆ. So force is towards right side and the displacement of the charge is towards left side. So left side ಗೆ displace ಆಗ್ತಾ ಇದೆ opposite direction ಅಲ್ಲಿ. That means work is done. So small charge ನ remove ಮಾಡ್ತಿರೋದ್ರಿಂದ ಅಲ್ಲಿ small work done ಆಗುತ್ತೆ. So small charge is nothing but only few amount of charges compared to the overall charges, right? So that is dq dash, right? So this is again the relation from the definition. Potential is equals to work done per unit charge, right? So small work done is equals to small potential, right? Sorry, small work done, that is by the small charge, right? So dw is equals to v dash into dq dash, right? So from the definition of the capacitance, C is equals to q dash by v. We need v dash, so v dash is equals to q dash by c, right? So we get the small work done for the total work done. So total work done is the total number of charges which are moved from second conductor to the first conductor. So hence the total work done W is equals to limit starts from 0 to Q, right? So substitute madi integration, right? So integration you can jump the step. So directly you can write from this step. So this steps to here and this steps to this steps, right? So ಇಲ್ಲಿಗೆ ಏನು ಮಾಡಿದ್ರು ಕೂಡ ನಾವು potential energy consider ಮಾಡ್ಕೊಂತೀವಿ, but in terms of capacitance and potential ಅಂದ್ರೆ half CV square. So that is the standard form, right? So this is the energy stored in the capacitor. So next question, move on to the next question, that is 7. Obtain the expression for effective capacitance of a two capacitors connected in series and parallel. So ಇದನ್ನ 3 marks ಅಲ್ಲಿ ಕೇಳಬಹುದು ಅಥವಾ 5 marks ಅಲ್ಲಿ ಕೇಳಬಹುದು. So resistance topic ಅಲ್ಲಿ ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಅದು ಸಿಲೆಬಸ್ ಇಂದ ರಿಮೂವ್ ಮಾಡಿದ್ದಾರೆ. So chances either they may ask this in 3 marks or in 5 marks, right? So 7th question, first, in series. So effective capacitance of a capacitor. So effective capacitance is nothing but if two or more capacitors in work ಮಾಡುತ್ತೋ, so the same work will be done by the single capacitor, right? So that we call as the effective capacitance, right? So effective capacitance ಅಂದ್ರೆ ಎರಡು ಅಥವಾ ಮೂರು ಕ್ಯಾಪಾಸಿಟರ್ಸ್ ನ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅಥವಾ ಪ್ಯಾರಲಲ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ನಮಗೆ ಔಟ್ಪುಟ್ ಬರುತ್ತೋ, so same output will be given by the single capacitor, right? So ಅಷ್ಟು ವರ್ಕ್ ಅಥವಾ ಅಷ್ಟು ಪವರ್ ಅಥವಾ ಅಷ್ಟು ಎನರ್ಜಿ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ. So that by the single capacitors, ಅಂತ capacitors ನ ನಾವೇನಂತ ಕರಿತೀವಿ, effective capacitors of effective capacitance, right? So first, two capacitors which are connected in series, right? So consider two capacitors of capacitance C1 and capacitance C2, right? So consider two capacitors of capacitance C1 and C2. So capacitors symbols ಏನು ಅಂದ್ರೆ two parallel lines ನ ಡ್ರಾ ಮಾಡಬೇಕು. So ಒಂದು ದೊಡ್ಡದು ಅಥವಾ ಒಂದು ಚಿಕ್ಕದು ಇತ್ತು ಅಂದ್ರೆ ಅದು ಬ್ಯಾಟರಿ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಆಗುತ್ತೆ. So capacitor symbol is two parallel conductors, right? So these two capacitors are connected in series, right? So one end of the first capacitor is connected to the another end of the second capacitor, right? So this is the series combination of two capacitors, right? Now these two capacitors are connected to the external source. So external source is nothing but the battery. ಸೊ ಮೊನ್ನೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದಾಗಲೂ ಕೂಡ ಬರ್ದಿದ್ದೀರಾ. ಸೊ ಎಕ್ಸ್ಟರ್ನಲ್ ಸೋರ್ಸ್ ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ, ಓನ್ಲಿ C1 C2 ಈ ತರ ಬರ್ದು ಲೆಫ್ಟ್ ಮಾಡಿದ್ದೀರಾ. ಸೊ ಕಂಪ್ಲೀಟ್ ಡಯಾಗ್ರಾಮ್ ಇರಬೇಕು, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಪ್ಲೇಸ್ ಅನ್ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್ when the two capacitors which are connected to the external source, that is the potential, right? So charges which are flown from the external source will be the same in both the capacitor C1 and in the capacitor C2. So series ಆಗಿರೋದ್ರಿಂದ ಇದರಿಂದ ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ, so the same charges will flow in both the capacitors, right? So capacitors ಅಲ್ಲಿ ಸೀರೀಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಎರಡು ಕೆಪಾಸಿಟರ್ಸ್ ಅಲ್ಲೂ ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋದು ಏನಿರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ, ಬಿಕಾಸ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋದು ಎರಡರಲ್ಲೂ ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ, ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಚಾರ್ಜಸ್ ಆರ್ flowing. So charges per unit time ನಾವೇನೆಲ್ಲ ಕರಿತೀವಿ, current ಅಂತ ಕರಿತೀವಿ, right? So charges will be the same on both the capacitors C1 and C2. So only the changes is potential drop. So V1 is the potential drop across the capacitor C1 and V2 is the potential drop across the capacitor C2. So right, so the total potential applied across the two capacitors is V. So the potential divided across the capacitor C1 and C2 is V1 and V2. So the total potential V can be written as V is equals to V1 plus V2. Right? So from the definition of the capacitance of a capacitor, right? So we call this one as first relation. So from definition of capacitance, C is equals to Q divided by V, right? So this is from the definition, capacitance C is equals to Q by V. So here for the first capacitance C1, it becomes C1, so Q will be the same on both the capacitors. So ಎರಡು capacitors allu charge ಏನಿರುತ್ತೆ, same ಇರುತ್ತೆ, right? So potential is V1, right? Similarly C2, that is equals to Q divided by V2, right? So C2 ಅಲ್ಲಿ ಕೂಡ charges same ಇರುತ್ತೆ, so potential ಏನಾಗುತ್ತೆ, V2 ಆಗುತ್ತೆ, right? So substitute V1 and V2. So this we can write V1 is equals to Q divided by C1, V2 is equals to Q divided by C2. So put the values or substitute the values of V1 and V2 in equation 1. So that gives what V is equals to Q divided by C1 plus Q divided by C2, right? So from these two we can take Q as common. We can write 1 by C1 plus 1 by C2. Calling this second equation, right? So next the important is we need to relate these two capacitors which are connected in series with the equivalent capacitance. So equivalent capacitance anta ಏನು ಅಂದ್ರೆ ಎರಡು ಕೆಪಾಸಿಟರ್ ನಮಗೆ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿ ಅಥವಾ ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿ ಇದರಲ್ಲಿ ಏನು ನಮಗೆ ವರ್ಕ್ ಆಗುತ್ತೋ the same work will be done by the equivalent capacitance. So series ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿರೋದ್ರಿಂದ, so equivalent capacitance or effective capacitance will take a CS. So ಈ ಡಯಾಗ್ರಾಮ್ ಕೂಡ ನೀವು ಮೆನ್ಷನ್ ಮಾಡಲೇಬೇಕು. ಸೊ ತುಂಬಾ ಜನ ಇದನ್ನ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ, ಓನ್ಲಿ ಇಷ್ಟು ಬರೋದು ಫೈನಲ್ ರಿಲೇಷನ್ ಬರೋದ್ರೆ ಅದಕ್ಕೆ ಏನು ಮೀನಿಂಗ್ ಇರಲ್ಲ. ಸೊ ಅಪ್ ಟು ದಿಸ್ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ದ ಮಾರ್ಕ್ಸ್. ಸೊ 3 ಮಾರ್ಕ್ಸ್ ಇತ್ತು ಅಂದ್ರೆ 1 ಮಾರ್ಕ್ಸ್ ಕೊಡಬಹುದು ಅಥವಾ 2 ಮಾರ್ಕ್ಸ್ ಕೊಡಬಹುದು, ರೈಟ್? So but this diagram is very important. So we are relating this series combination with the equivalent capacitance CS, right? So again the applied potential is same. So from this, again from the definition, CS is equals to Q divided by V. So ಎರಡು ಕೂಡ potential same ಇರೋದ್ರಿಂದ charges ಎರಡರಲ್ಲೂ ಕೂಡ flow ಆಗ್ತಾ ಇರೋದು same ಇರುತ್ತೆ. So hence CS is equals to Q by V, right? So this we can take third relation. So V is equals to Q divided by CS. Third relation, right? So now observing equation 2 and 3. So in the LHS we have the potential V, right? So first potential V, illi now if we take an example, so here we are applying 10 volt potential means, so here also we are applying the 10 volt. So potential eradu circuit allu kuda same irodrinda we can equate the equation 3 and 2, right? So from equation 2 and 3, Q by CS, that is equals to Q into 1 by C1 plus 1 by C1, right? So in the LHS also we having Q, in the RHS also we having Q. So get cancelled. So equivalent capacitance when connected in series we get 1 by Cs is equals to 1 by C1 plus 1 by C1. So two capacitors under illige end ಆಗುತ್ತೆ, right? So ಇದು ಕೂಡ ಸಿಂಪಲ್, ತುಂಬಾ ಸಲ ಕೇಳಿದ್ದಾರೆ, right? So first ಎರಡು ಕಡೆ ಚಾರ್ಜಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ so here also q, here also q, right? So only the potential ಏನಾಗುತ್ತೆ ಡಿವೈಡ್ ಆಗುತ್ತೆ. So total potential v, that we can write v1 plus v2. So from the definition of the capacitance c1 is equals to q by v. So here we need the potential across the first capacitor, so v1 is equals to q by c1. Similarly the potential across the second capacitor v2, that is equals to q by c2, right? So v is equals to v1 plus v2, that is q by c1 plus q by c2. So we can take q common, so we can take this relation as the second relation, right? So now this whole circuit or whole combination is equals to the single capacitor. So ಇಲ್ಲಿ n number of capacitors connect ಮಾಡಿದ್ರು ಕೂಡ ಅದು ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ one single capacitor ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಸೊ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, effective capacitance. So that effective capacitance is CS, right? So CS is equals to q by v. So potential v is equals to q by CS. So ಎರಡು ಕಡೆ potential same ಇರೋದ್ರಿಂದ we can relate the equation 2 and 3. So finally we get 1 by CS is equals to 1 by C1 plus 1 by C2, right? So ಈ ಎರಡು diagrams important. So without diagrams ಬರೆದ್ರೆ meaningless. So ಅಲ್ಲಿ ನಿಮಗೆ complete 0 marks ಇರುತ್ತೆ, right? So next in that second one, parallel. So series ka matlab parallel confuse agmadi, right? So series anta kelidra parallel kelidra series. So diagrams egirutte steps change agutte. So aduna ಒಂದು ಸ್ವಲ್ಪ careful ಆಗಿ observe ಮಾಡಿ, right? So parallel means consider two capacitors of capacitance C1 and the another capacitance of capacitor of capacitance C2, right? So how we connect the two capacitors in parallel means, so left end of both the capacitors are connected to each other, and also the right side of the plates are connected to the each other, right? So these two is connected to the external source, that is external potential V, right? So now the current is flowing in the circuit. So current flows nothing but the charges are flowing. So at this junction, so junction alli enagutte current divide agutte. So again from the Kirchhoff junction rule, so junction rule alli current divide agutte. So current divide agtide andre automatically the charges are dividing, right? So the total number of charges which are flowing in the circuit, if that is q, then the charges are divided into two branches. So C1 capacitor alli charge Q1 irutte, so C2 capacitor alli charge Q2 irutte, right? So because the current divides at the junction, so again when it comes to here, the two charges Q1 and plus Q2 will again becomes Q, right? So current divide agodrinda charge kuda divide agutte. Then so across the parallel combination, the potential remains same across the each capacitor. So parallel ನಾವು ಏನೇ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರು ಕೂಡ ಅಲ್ಲಿ potential ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So from this relation we can write the relation, that is q is equals to q1 plus q2, right? So from the definition of capacitance, C1 is equals to q1 by v, C2 is equals to q2 by v, because potential is same across the two capacitors. So parallel potential ella kadegu ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So from this we can relate, we need q1, so q1 is equals to c1v, q2 is equals to c2v, right? So substitute the values of q1 and q2, that is c1v plus c2v. So from this we can take common c1 plus c2. So call this one as first relation, right? Or call this one as the first relation, so this becomes second relation. right? So again, this combination is equivalent to the one capacitor. So that capacitor will take an effective capacitance, that is Cp. So suffixal P represents what? Capacitors which are connected in parallel, right? So potential could I the same with that, right? So Cp is equals to Q by V. So we need Q, that is equals to V into Cp. So call this one as third relation, right? So here the relation again from second and third relation LHS Q same ಇದೆ because the charges which are flowing in the circuit is same. So ಇಲ್ಲಿ Q ಅಷ್ಟು flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೂಡ flow ಆಗ್ತಾ ಇರೋದು Q. So ಎರಡರಲ್ಲೂ same charges flow ಆಗ್ತಿರೋದ್ರಿಂದ we can relate the equation 2 and equation 3. Right? So from equation 2 and 3 V into Cp that is equals to V into C1 plus C2. So in the RHSB, in the LHSB, get cancels. So we can write Cp that is equals to C1 plus C2. So this is the two capacitors which are connected in parallel, right? So effective capacitance. So ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು ಏನು ಅಂದ್ರೆ ಸೀರೀಸ್ ಅಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಸೊ ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಚಾರ್ಜಸ್ ಡಿವೈಡ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇದು ನೆನಪಿಟ್ಟು ಅಂದ್ರೆ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ derive the relation. So but important, ಈ ಎರಡು diagrams ಇರಲೇಬೇಕು. So without these two diagrams, so there is no meaning for the relation, right? So 3 marks ಕೇಳಿ ಅಥವಾ 5 marks ಕೇಳಿ ಎರಡು diagram compulsory. So ನೀವು ಈ diagram ಬರೀಲಿಲ್ಲ ಅಂದ್ರೆ ನಿಮಗೆ up to here only they will give the marks. So ಇದಾದ್ಮೇಲೆ next ನಿಮಗೆ ಏನೇ ಬರೆದಿದ್ರು ಕೂಡ marks ಕೊಡೋದಿಲ್ಲ, right? So this is the effective capacitance of two capacitors which are connected in series and parallel, right? So move on to the next question, that is derive the expression for drift velocity of free electrons in a conductor, right? So derivations ಎಲ್ಲ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, ಎಲ್ಲೂ ಮಿಸ್ಟೇಕ್ ಮಾಡಬೇಡಿ, ಈಸಿ ಇದಾವೆ, ರೈಟ್? ಸೊ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಸ್ಕೋರ್, ರೈಟ್? ಸೊ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ drift velocity, that is Vd. So drift velocity is defined by V suffix d, right? So for that, consider a conductor. So drift velocity we are going to discuss in a conductor, right? So this is one conductor, right? In a conductor, the charge carriers are the electrons. So conductors ಅಲ್ಲಿ charge carriers ಅಂದ್ರೆ ಯಾವುದು ಅಂದ್ರೆ electrons, right? So the conductor consists of many number of the electrons, that is free electrons which are free to move inside the conductor. So ಎಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ? ಫ್ರೀ ಆಗಿ inside the conductor ಅಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ, right? So these are the electrons. So electrons, or we can say that one as a charge carrier. So particularly conductor are considered ಮಾಡಿರೋದ್ರಿಂದ, so electrons are the charge carriers, right? So initially these electrons are at rest. So rest ಅಂದ್ರೆ ಅದರ velocity ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. That is the initial velocity. So there is no velocity for the electrons. So they are ready to move or free to move inside the conductor, right? So when this conductor is connected to the external source, so ಈ conductor ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ? External source ಗೆ connect ಮಾಡ್ತಾ ಇದೀವಿ, that is battery. That means we are applying the potential across the ends of the conductor. So across the ends of the conductor, so potential apply ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ, so current is flowing in the conductor. So conductor ಅಲ್ಲಿ ಏನು flow ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ? Current flow ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. So due to this potential, so electric field is generated, right? So electric field is generated from positive terminal to the negative terminal. So here it is positively charged, so here it is negatively charged. So potential ಈ end ಅಲ್ಲಿ positive ಇರುತ್ತೆ, ಈ end ಅಲ್ಲಿ negative ಇರುತ್ತೆ, because we applied the potential like that, right? So plus minus. So electric field is generated, right? So electric field ಇದೆ ಅಂದ್ರೆ ಏನಿರುತ್ತೆ ನಮಗೆ? force irutte, right? So due to that force the electrons are get started to move. That means they are getting accelerated due to that force. So due to that force the electrons are accelerated in the opposite direction of the electric field, right? So that is because electrons are negatively charged, right? So force direction ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ನಮಗೆ acceleration ಕೂಡ ಇರುತ್ತೆ, right? So this is the initial consideration. So initially we considered one conductor. So in that conductor electrons are the charge carriers. So initial case ಅಲ್ಲಿ they are not ready to move. So hence its initial velocity ಏನಿರುತ್ತೆ 0 ಇರುತ್ತೆ. When this conductor is connected to the external source, then the current is flowing in the conductor. That means the electric field is generated due to this electric field. So force is acting on these free electrons. So due to this free force the electrons are gets accelerated. That means the electrons are drifted. So they starts to move into the velocity, that is VD, drift velocity. They are start to move into the velocity. That velocity is the drift velocity. That is the average velocity for the collision between the two electrons or nearby electrons. So our time na ನಾವೇನಂತ ಕರಿತೀವಿ relaxation time or mean free time, that is tau, right? So idu collision ಆಗೋಷ್ಟರಲ್ಲಿ ಎಷ್ಟು acceleration ಆಗುತ್ತೆ ಅನ್ನೋದ time ನ ನಾವೇನಂತ ಕರಿತೀವಿ relaxation time. So collision between the two electrons, then the electrons gets accelerated in that time. So that time is the mean free time, right? So from this Newton's second law of motion, F is equals to m into a, right? So electrons ge namge mass irutte. So due to the second law, Newton's second law of motion, we relate F is equals to mass into acceleration, because due to the force electrons are gets accelerated, right? So in the second case, due to the electric field the force is acting on the electrons. So electric field idರಲ್ಲಿ ನಮಗೆ electric force ಇರುತ್ತೆ. So ಆ force ಇಂದ electrons ಏನಾಗ್ತಾ ಇದೆ accelerate ಆಗ್ತಾ ಇದೆ. So that is the relation between the force and to that of the electric field E. So ಎಲ್ಲ vectors ಇರೋದ್ರಿಂದ F is equals to m into a. A is also a vector, right? So F is equals to minus E into E. So why minus E? Because the charge carriers are the electrons. So electrons we can take Q is equals to minus E. That is opposite to that of the electric field, right? So electron ಯಾವ direction ಅಲ್ಲಿ move ಆಗುತ್ತೆ ಅಂದ್ರೆ electric field ಗೆ opposite direction ಅಲ್ಲಿ move ಆಗ್ತದೆ. That also indicates by negative sign, right? So from these two relations the electrons are getting the same force. So hence we can relate ma is equals to minus E into E, right? So from this we can get the acceleration a is equals to minus E divided by m, calling this as the first relation, right? Now these electrons are moving from one end of the conductor to the another end of the conductor. So it takes the time, that is the relaxation time, collision between, to get it accelerating, right? So initially velocity ಏನಿರುತ್ತೆ 0 ಇರುತ್ತೆ. These are moving, that means these are getting accelerating. So from the equations of motion, so again from the first year equations of motion, V is equals to U plus A into T, right? So here initial velocity is 0 and the electrons are getting moving into the velocity. So that velocity we call as the drift velocity. So V is equals to Vd, that is equals to U is equals to 0. So acceleration A is equals to minus E divided by m, and the time is the relaxation time tau, right? So from this the drift velocity Vd is equals to minus E by m into tau. So this is the relation for the drift velocity, right? So drift velocity relation. So E concept, this is from the first year, right? So Newton's second law of motion, and this is also from the first year, that is equations of motion, right? So here the equation we can find the drift velocity. So ಯಾವಾಗ electrons velocity change ಮಾಡುತ್ತೆ drift velocity ಆಗುತ್ತೆ, electrons move ಆಗೋಕೆ start ಆಗುತ್ತೆ with the velocity, means when external potential is applied. So external potential apply ಮಾಡಿದ್ರೆ ಮಾತ್ರ electrons gets accelerated. So it gets accelerating means it changes its velocity. So accelerate ಆಗ್ತಿದೆ ಅದರಲ್ಲಿ velocity change ಆಗ್ತಾ ಇದೆ. So 0 ಇದ್ದಿದ್ದು some velocity, so that velocity is the drift velocity. So velocity, acceleration, these two are moving in opposite direction to that of the electric field. So hence the negative symbol, right? So simple, ತುಂಬಾ explanation ಕೂಡ ಇಲ್ಲ. So similar mathematical steps ಇದೆ ಅಷ್ಟೇ, right? So you need to remember force. So ಎರಡು force relation ತಗೊಂಡು next find the acceleration, then velocity. So initially u is equals to 0 when there is no external potential is applied. So ಯಾವುದೇ external potential apply ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಅವಾಗ electrons move ಆಗ್ತಾ ಇರೋದಿಲ್ಲ. So ಅದಕ್ಕೆ ಅದರದ್ದು velocity ಏನಿರುತ್ತೆ 0. u is the initial velocity and v is the final velocity. So that final velocity is the drift velocity, right? So next, derive j is equals to rho e, right? Ninth question. So where J is the current density, right? So and E is the electric field and rho is the conductivity, right? So again the same conductor which is applied to the external source, the current is flowing. So hence we are getting the current density here J. It is also the vector. So current moving per unit area of cross section, right? So ಅದನ್ನ ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So ಈ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಕೂಡ ಯೂನಿಟ್ ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ನಾರ್ಮಲಿ ಟು ದ ಏರಿಯಾ. ಸೊ ಕರೆಂಟ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಸರ್ಫೇಸ್ ಏರಿಯಾ. ಸೊ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಕರೆಂಟ್ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಫ್ರಮ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ದ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ, ಇದು ಕ್ವಶನ್ ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಂಗಿಲ್ಲ, ರೈಟ್? ಸೊ ಫ್ರಮ್ definition of current density, right? So current density, capital J, that is equals to, it is the ratio of the current moving in a unit area of cross section A, right? So I is the current and A is the area of cross section, so that we call as the current density, right? So that we can take equation 1, right? So now the conductor and A is the area of cross section of the conductor. Then the relation for E and V, right? So we know the relation for E and V, that is E is equals to V divided by L. So iduna nanne class alli kuda hididu, previous class alli kuda iduna derive madidvi, relation between E and V. So very important, right? So E is equals to minus dV by dl. So ಇಲ್ಲಿ overall length ತಗೊಂಡಿದ್ದೀವಿ, overall total potential ತಗೊಂಡಿರೋದ್ರಿಂದ E is equals to V by L, right? So from this relation V is equals to E into L, right? So conductor which is connected to the external potential and the current is flowing. So from Ohm's law, V is equals to IR, where R is the resistance of the conductor. So substitute V, that is I into R, that is equals to E into L. So from the definition of the resistance R, we have the relation I into, so resistance R is equals to rho L by A, right? So rho L divided by A, that is equals to E into L, right? So that is because R is equals to rho L by A, resistance of a conductor, relation between the resistance and resistivity, right? So in the LHS also we have L, in the RHS also we have L, that is get cancelled. So L get cancelled. So first relation ಅಲ್ಲಿ ಏನಿದೆ ನಮಗೆ I by A. So ಇಲ್ಲಿ ಕೂಡ ಅದನ್ನ ನಾವು obtain ಮಾಡ್ಕೊಂತಿದೀವಿ, that is I by A, that is equals to E by rho. Right? So calling this as second equation, right? So from first and second equation, so in place of I by A, we can replace that by E by rho, right? So J is equals to E divided by rho. So bracketally from equation 1, right? So from equation 1, in place of I by A, So I by A ಗೆ ನಮಗೆ ಒಟ್ಟೇನ ಆಗಿರೋದು E by rho. So in place of I by A we can write J is equals to E by rho, or the equation 1 becomes J is equals to E by rho, right? So rho is the resistivity. So current density is equals to sigma into E. So rho ಏನಿದೆ ನಮಗೆ constant ಇದೆ. So that constant is replaced by one more constant. So that is conductivity. Rho is the conductivity, and we can write, because rho is equals to sigma is equals to 1 by rho. So this is the final derivation. J is equals to rho into E. So in case they mention in vectors, so wherever J and E, so you need to write the vector form, right? So vector alli idu andre ella kadenu vector alli represent ಮಾಡಿ, right? So simple expression by using these relations, that is start from the current density. Current density is equals to I by A. So from the another relation between E and V, so E is equals to V by L, V is equals to E into L. So from Ohm's law, V can be replaced by IR. So substitute and we get the relation J is equals to rho into E, right? So remaining we will discuss in our next class, right? Thank you.